Now, in this recent review, Unit 1, we have finding unknown angles and proofs. I am going to show you how to prove this 21st question. What is this 21st is saying? In the figure to the right, PQ is parallel to RS, and you have to prove angle PTR is equal to this P plus R here. You have to prove that angle is P plus R. For that, how I do that? First I make a small construction. I draw a parallel line like this through this T. This parallel line is parallel to this line and also this line. That means I can call this point as some K. So draw TK parallel to this PQ parallel to this RS. That's what I made here. Now what happens, you see here, when these two lines are parallel, if this is P, this angle must be alternate interangle to this. These two are equal. That means if this is P, this must be P. And in the same way, for this line and for this line, since they are parallel and this is a transversal, this angle and here this angle, they are alternate interangles, they are equal. If it is R, this must be R degrees. Therefore, when you take this PTR, that is P plus R. So in this way we have to prove that problem. But for that, how do we write the steps? See here, I am writing directly angle QPT is congruent to angle PTK, which is equal to P degrees. The reason is alternate interior angles congruent. That is the reason for the first one. And the second point is angle angle SRT is congruent to angle RTK, that is equal to this R degrees. The reason for the second one also same thing, alternate interior angles congruent. Now the third point, angle PTK plus angle RTK is equal to P plus R degrees, because angle PTK is P, angle RTK is R. That's why when we add, we get P plus R. This is, the reason is substitution property. And again, this PTK plus RTK I am replacing with angle PTR. That is equal to P degrees plus R degrees. This is also substitution property. See here, angle PTR I have proved P degrees plus R degrees. That is what we want. So this measure of angle PTR, I got P plus R, hence proved. So in this way I have to prove. So practice, after watching this, you try to write without seeing. Then only you will learn how to prove it. And see this 22nd question. Here in this, angle Y plus angle Z is exactly equal to angle W plus angle X. For this, I make a small, here I name this angle as some P degrees. P degrees. Now you see the first thing, in this triangle, this angle Y, measure of angle Y plus measure of angle Z plus this is a measure of angle P. These three sum is 180. What is the reason? The reason is sum of three angles. Sum of three angles of a triangle. Sum of the three angles of a triangle is 180. That's why I wrote like that. And if you see the second one, this bigger triangle, Here also this x degrees plus w degrees plus p degrees. When you add these three, that is also 180, because this is the bigger triangle, that sum of the three angles is 180. So I can write sum of three angles, one more time, of a triangle. That's why I am writing 180. Now I can add these three equal to 180, and these three is 180. That means y degrees plus z degrees plus p degrees is exactly equal to x degrees plus w degrees plus p degrees. What is the reason? This is a substitution property. I used the substitution property. Now if you see, this p and p gets cancelled, therefore y degrees plus z degrees is exactly equal to x plus w degrees. This is cancellation law. Cancellation law allows us to cancel this p and p. That's why we can equate them. So this is what we want here. Measure of y plus measure of z is equal to measure of w plus measure of x. That's what we got here. Hence proved. Hence proved. So you practice in the same way. After watching this, you try to do without seeing. Then you can get good practice of this. And after this, we have 23rd question. This is also same type. So here I make a construction. I draw a parallel line EF. This is EF parallel to this AB and parallel to this CD. So draw EF parallel to AB parallel to CD. What happens, here, when this is x, this must be x degrees. When this is y, because these two are corresponding angles, they are equal. In the same way, when this is y, this is also y degrees. They are corresponding angles. But this z is the total of this x and y. Therefore, z is equal to x plus y. Like that we prove. For that first step, what I do, angle. So I can name this point as some P, and this point as some Q for our reference, and this point as some R. Now, and here I can name this as some VW. See here, VPB, angle VPB is congruent to angle PQF. Each is equal to x degrees. The reason is corresponding angles congruent. And next, second point, angle WRD is congruent to angle RQF. Each is equal to y degrees. The reason is same thing, corresponding angles congruent. Now, third point, angle Z is equal to x degrees plus y degrees, because this angle PQR. So I can write, instead of that, I write third step like this for you. Angle PQR is congruent to angle PQF plus angle RQF. This is angle addition property. Angle addition property. Now, fourth one, for angle PQR, I can write z degrees, and angle PQF, I write x degrees, and angle RQF, I write y degrees. What is the property I used? Here I used a substitution property. And if you see here, z is x plus y, that's what we got here. Hence, proved. So in this way, you have to prove this 23rd. So after watching this, you have to do without seeing in the same way. Then only you will become master about this. Thank you.